Welcome back, scholars. Mr. Spears here with another lesson from the world of science. Today's lesson is a continuation of what we learned just last night, and that is this whole notion of significant digits. Now, if you don't know what a significant digit is, you need to go and watch the previous video to this lesson and make sure that you got that down pat before you continue on with this one. So without further ado, let's take a look at some of the calculation rules in science. When you make a calculation in this class, I want you to consider two rules. When you're making a calculation, you're either going to be multiplying or dividing or doing some type of an addition or subtraction most of the time. And there are two rules to go with each situation. If you're multiplying and dividing, the value in your calculation with the fewest number of significant digits determines how many significant digits are in your answer. And if you're adding and subtracting numbers to get a calculation, the value in your calculation with the fewest number of places after the decimal point determines how many places after the decimal point your answer must include. Now I'm going to give you plenty of examples to show you how this is done, but these are the two rules for calculation. Okay, first I'm going to show you about 3 examples for using the rule of when multiplying and dividing. My first example here, I have 59.01 times 22. Alright, so if you'll recall, the rule on the previous page said that when multiplying and dividing, my answer has to include the same number of significant digits as the value in my calculation that has the fewest. So the first thing I need to do is I need to examine both of these numbers and find out how many significant digits they have. Alright, so looking at 59.01, I've got 4 significant digits using the Pacific rule. 22, using the Atlantic rule, has just 2 significant digits. Alright, so between these two numbers, 22 has the fewest number of significant digits, and that is 2. So when I do my answer, 59.01 times 22, I'm going to punch that into the calculator. I see that my answer comes out on the calculator to be 1,298.22. Alright, now remember the rule said that I can only have the same amount as the value from my calculation that has the fewest number of significant digits. So this answer right here needs to be rounded to 2 significant digits. Alright, so all of these digits are significant according to the Pacific rule. My first 2 significant digits here are the 1 and the 2. This 9 is going to round that 2 up to a 3. And then I'm going to drop all that remains. I have 2 digits here that were before the decimal point, so I'm going to replace those digits with zeros. So my answer is 1,300. Example number 2. In this example, I'm going to divide 34.00 by 0.983. So just like with multiplying, dividing, it's the same rule. My answer needs to have the same amount of significant digits as the value in my calculation that has the fewest. So if I go through here and I use my Pacific rules for determining significant digits, this number here, 34, has 4 significant digits. 0.983, again, I'm going to use my Pacific rules. And I've got 1, 2, 3, so 0.983 has 3 significant digits. Alright, so when I punch this into my calculator, 34.00 divided by 0.983, I get an answer from the calculator of 34.58799, and then a bunch of other numbers as well. Alright, so remember this answer needs to be rounded to the value that had the fewest significant digits in my calculation. That would be 3 significant digits from the 0.983. So when I round this, I'm going to look at my first 3 significant digits. That's the 3, the 4, and the 5. This 8 is going to round that 5 up to 6. And now I'm going to drop everything else. Now I'm not going to replace these with zeros because these digits that I trimmed off, they are come after the decimal point. So my answer rounded to the correct number of significant digits is 34.6. Alright, in example 3, I want to show you a problem that has multiple steps. In this problem, I have to multiply the numerator, and then I got to divide by this denominator. So what do? Well, if you encounter a situation like this, do your multiplying and dividing all at once. And then in your answer, you can apply your calculation rules. Okay, so let's take a look at the top. Take a look at these numbers. How many significant digits do they have? My first number here has 3 significant digits. My next number, written in scientific notation, I'm going to ignore this times 10 to the third and just concentrate on the 4.5. This has 2 significant digits. And then the denominator, using the Pacific rules, I've got 1, 2, 3, 4, 5 for a total of 5 significant digits. Okay? So as you can see here, the 4.5 times 10 to the third, that is my limiting value here. My answer needs to be rounded to 2 significant digits. Alright, so let's punch this in our calculator. 0.138 times 4.5, and then I'm going to use the E button on my calculator. That means times 10. And then I'm going to put 3 for my exponent, and then I'm going to divide by 50.045. Alright, so my calculator gives me a bunch of digits. I'm just going to put a few. 12.40832, and then some change. Alright, recall the rules for multiplying and dividing. My answer needs to be rounded to 2 significant digits. Why? 2, because this value of 4.5 times 10 to the third has only 2, and I'm limited on whatever significant digits are in that value. Alright, so all of these digits are significant, and my first 2 are the 1 and the 2. I look at the third, the fourth, or digit number 4, I'm sorry. So my first 2 digits are the 1 and the 2. I look at the third digit to see if it's going to round the 2. That 4 will not round the 2. So I drop everything to the right. All of these digits come to the right of the decimal, so I'm not going to replace them with zeros. So my answer becomes simply 12. So these rules for multiplying and dividing, one of the things I like to teach my students is when you're multiplying and dividing, I want you to think of a chain made of a bunch of links. That chain is only as strong as its weakest link. This calculation is only as precise as the value in the calculation with the fewest number of significant digits. And so that's why we have the rule for multiplying and dividing. All right, what about addition and subtraction? Well, there's a different rule for those types of calculations. Here I'm given the task of adding 6.708 to 1.2. Now when you're adding and subtracting, one of the things I like to do is to write it out exactly the way you see here. And what I'm looking for is I want to line up these decimal points. Because the rule on adding and subtracting and what your answer should be is based upon how many places after the decimal point each value has. Alright, so if we analyze these numbers, 6.708 has 3 places after the decimal. 1.2 has just simply one place after the decimal. So the rule is when I add these together, my answer can only have as many places after the decimal as the value in my calculation that has the fewest. So since 1.2 only has one place after the decimal, my answer will only have one place after the decimal. Alright, so when I add these guys up, I get 0, 8, 7 and 2 make 9, point, and then 1 and 6 make 7. Alright, so I'm going to round this so that I have just simply one place after the decimal. So I look at the next number over, that 0, I'm checking to see if it'll round it up. 0 does not round that 9, so I'm going to drop everything else off of that number, and so my answer becomes 7.9. In example 2, I'm subtracting 0.5559 from 44.67. The rule for addition and subtraction are the exact same thing. Alright, so like I said, I like to visualize where my decimal points are, okay, and I like to line them up. So I'm going to put 0.5559 right under the 44.67. And I'm going to subtract those two. Alright, when I do that, it's very clear how many places after the decimal each has. 44.6 has 2 places after the decimal. 0.5559 has 4 places after the decimal. Alright, according to the rule for addition and subtraction, my answer can only have the same number of places after the decimal as the value in my calculation that has the fewest. That would be 44.67, and that would be 2 places after the decimal. So when I punch this into my calculator, 44.67 minus 0.5559, I end up with an answer of 44.1141 off of the calculator. Alright, now remember, this answer can only have 2 places after decimal according to our rule for addition and subtraction. So the second place after the decimal is right there. I look at this 4 to see if it will round to 1. It does not. So I'm going to take off these last 2 digits, and now my answer is 44.11. So one thing you'll notice is that when multiplying and dividing, it's based upon which value has the fewest number of significant digits. When we get to addition and subtraction, it's simply based upon how many places after the decimal our values in our calculation have. Alright, my last example, I'm going to kind of combine both rules together. You'll notice that in the numerator I need to add 23.60 to 3.4. And then after I do that, I need to divide it by 4.9040. Now when you get into situations like this, it's always best to take care of your addition and subtraction separate from your multiplication and division. Alright, so basically order of operations if you've been paying attention in math class. So first I'm going to start by adding up the numerator. Okay, I'm going to rewrite 3.40 right above my 23.60, and I'm going to add up those decimal points, or I'm going to line them up. And here it's very simple to see. The 3.4 has 1 place after the decimal. 23.60 has 2. So this answer between the addition of 23.60 and 3.4 needs to have just 1 place after the decimal. So 23.60 plus 3.4, I get for an answer 27.000. Okay? So 1 place after the decimal would just simply be this 0 right here. These other zeros are not going to round that up, so I just mark them off. And so my numerator, the answer of my numerator becomes 27.0. Okay, let's not forget about our denominator, the 4.9040. That's the second part of this calculation. Okay, here we can see now we're going to apply the rule for multiplication and division. 27.0 has 3 significant digits. 4.9040 has 1, 2, 3, 4, 5 significant digits. My answer can only have the same amount as my weakest link, or the value with the fewest number of significant digits. So my answer is going to be rounded to 3. When I punch this into the calculator, 27.0 divided by 4.9040, my calculator spits out an answer of 5.50570 and some change. Alright, now that needs to be rounded to 3 significant digits. So using the Pacific rules, here are my first 3 significant digits. I look here at this fourth. Will that 5 round up to 0? Yes, it will. So I get 5.51. And then I'm going to chop off the rest of that number. Because all of those digits come after the decimal, I don't need to replace them with zeros. So my answer becomes 5.51. And there you go.